Hey Math 6, happy Wednesday. Hope you're doing well. It was great to see you yesterday in our Google Meet going over two-step equations. Today we are going to find patterns by looking at tables and write equations in order to fill in missing parts of the table. But before we get into that, make sure that you have a little math laugh for yourself, courtesy of Catherine. If you guys find any funny math memes, make sure you email them my way. All right, let's get rolling with a mental math warm-up. We're going to start with 18 and add 66. You're going to divide by 3. Multiply by 2, and subtract 32. If you need some time, press pause. You can rewind and listen to that again, but you should end up with 24 as your final answer. All right. You all did wonderfully with balancing equations yesterday. Now you know how to do that if you have more than one operation, which is super exciting. The problems we're going to look at today and the equations we're going to be writing today are actually only going to involve one operation. So when we're looking at patterns and describing them, it's just going to be with adding, subtracting, multiplying, or dividing today. So let's take a look here. Here we have a table, and then there's a situation that describes the table over on the right-hand side. It says the table shows the cost of weekend tickets to the Slide and Splash water park. Find a pattern between the number of tickets, N, and the cost of the tickets. How much would 6 tickets cost? Write a rule and an equation that tells the pattern. All right, so we know that 3 tickets, that's the number of tickets, costs $16.50. What we don't know is how much 1 ticket costs. So I want to figure that out. It's almost like finding the unit rate. So I'm going to put my variable as t, and it's going to be equal to 1 ticket, or the cost of 1 ticket. So I will show you my variable here, the cost of 1 ticket. So if I have 3 tickets, I'm looking here at my table, 3 is my number, times the cost of 1 ticket is going to equal $16.50. So 3 times the cost of 1 equals $16.50. Go ahead and pause here, and I want you to figure out what t, the cost of 1 ticket, would be equal to. I'll see you back here when you're ready. You're back. All right. I am hopeful that you balance that equation by dividing both sides by 3. So we should get t equals $5.50. So by knowing the cost of 1 ticket, $5.50, that's going to help us figure out the cost of 6 tickets. And it's going to also help us check to see if the other numbers in the table match. That's a good way that we can check our answer right away. Let's plug in that $5.50. 3 times 550 gives you $16.50. 4 times 550 gives you 22. 5 times 550 gives you 27.50. So now you can plug in the amount of 1 ticket, t, to figure out what 6 tickets would cost. So now my equation is going to be 6 times t, and I know that t was $5.50. I'm going to figure out what that is equal to. So 6 is my number, $5.50 was my t, that was my cost of 1 ticket. So go ahead and pause and figure out what the cost of 6 tickets would be. You could have used mental math, you could have done the algorithm, you could have done partial product, but no matter what strategy you used, you should have gotten $33 for 6 tickets. And we did that by creating an equation. The number n times 550 will give you the cost. So that's also our rule too. It's something that will work every single time to get us the cost. So n times $5.50 equals the cost. That's our rule. So no matter what number you plug in for n, the number of tickets, you're always going to multiply it by $5.50 to get your cost. Let's take it a step further. We have the same chart here, and I plugged in the $33 that we just found. We have the same scenario up here, but we have a new question. How much will 12 tickets cost? All right, so we know the number of tickets. It's 12. So I'm going to plug that in to my equation here. 12 tickets times $5.50 equals C, equals my cost. So pause and go ahead and solve this. Use the table to help you as well, but figure out how much 12 tickets would cost. All right, you're back. Some of you might have done the standard algorithm or partial product. I'm willing to bet that some of you just looked at the chart and you saw that 6 tickets equals $33. So I think you just doubled that to find 12. So 33 doubled would give you $66. Either way, 66 is correct. 12 tickets would cost $66. So you'll notice these problems aren't especially difficult. It's just having you look at patterns in tables and connect that to our work around 1- and 2-step equations. Okay, we're going to do one more problem before I set you free to take a look at today's practice. Here we have Talia's age and Brendan's age. The table shows Brendan's age as B, and it shows Brendan's age when Talia, represented by T, is ages 7, 9, and 10. We're going to write a rule and an equation that describes the pattern that's shown in the table, and then we need to fill this blank in. So I'm going to give you a moment to think about the relationship between Brendan's and Talia's age. I personally noticed right away that Brendan is younger than Talia. So I know something's going to have to be added to Brendan's age to get to Talia's age. Are you noticing that too? So I'm going to plug in what I see right up here. I'm going to say Brendan's age is 2 plus X equals 7. Now, using the easy one-step equation, I can figure out that X is equal to 5. So now I'm wondering if I can plug that in for every single one. My X is equal to 5. Let's see. 4 plus 5 is 9. 5 plus 5 is 10. So what plus 5 equals 12? Now I have X plus 5 equals 12. Really, it should be Brendan's age plus 5 equals 12, which is Talia's age. So again, I can do a one-step equation here to figure out B, Brendan's age. Okay. And I should get Brendan's age as 7. Plugged 7 in here for Brendan's age. So now I know that no matter how old they get, Brendan's age plus 5 will give me Talia's age. So when Brendan is 50, Talia will be 55. So there you go. You have a rule and an equation, and we did some problem solving in the table. It's combining a lot of awesome things in math that you already know. So today you will head over to Google Classroom. Everything is still linked in the DLP. Just look for today's date when you hop over to Google Classroom, and it will show you the assignment. Please, please, please make sure you're pressing turn in when you're finished your work. Tomorrow is Thursday, so I will see you at 11 o'clock in our Google Meet. All right, email me if you have any questions, and I'm looking forward to seeing you all tomorrow at 11. Have a great rest of your Wednesday.